It's a Tuesday morning. You walk out to grab the mail, coffee still in hand, maybe still half asleep, and there it is, coiled up near the garden bed, right next to the front path you walk every single day. A snake, just sitting there like it owns the place. Now maybe you're the type who doesn't mind them. Maybe you know most snakes are harmless, that they eat rodents, that they're just passing through. But most people freeze. The coffee goes cold, the mail can wait. And here's the thing, you're not alone in this. Millions of homeowners deal with snakes on their property every year. People with kids running barefoot through the backyard. People with small dogs. People who just want to feel safe in their own yard, without scanning every shadow before they take a step. So what do? You go to the store, you buy whatever's on the shelf. Some chemical spray, some granules in a bright orange bag, something that promises to keep snakes away. You spread it around the perimeter. Maybe it works for a week, maybe it doesn't work at all, and you're back to square one, spending money on a product that the manufacturer hopes you'll keep buying forever. But what if there was something else? Something that has been working for centuries across dozens of cultures on every continent where snakes are a problem. Something natural, something cheap, something so effective that a major research program was quietly shut down in 1961 to make sure you'd never hear about it. One seed. That's all it takes. It sounds almost too simple, doesn't it? One seed. Not a system. Not a subscription. Not a 12-step perimeter treatment that requires you to reapply every time it rains. One seed, crushed between your fingers and the snakes stop coming. The seed in question comes from the Osage orange tree. You may know it by one of its other names: hedge apple, horse apple, monkey brain, mock orange. The tree itself is unremarkable to look at. It grows across the central and southern United States, tough and thorny. The kind of tree that farmers used to plant in dense rows as natural fencing before barbed wire existed. The fruit it produces is strange-looking, bright green, wrinkled, roughly the size of a softball, with a bumpy surface that does look, if you squint, a little like a brain. Most people who grew up in rural areas walked past these trees their entire lives without giving them a second thought. That fruit, that ugly, heavy, oddly textured fruit. Inside it are seeds. And those seeds contain something that changes the entire equation. But here's what's important to understand. This isn't fringe knowledge. This isn't something buried in an obscure archive or whispered between herbalists in some remote corner of the world. This information has been sitting in plain view for generations. Farmers knew it. Indigenous communities knew it. Rural households across Appalachia, across the Midwest, across parts of Europe and Asia where related plants grow wild, they knew it. Grandmothers knew it. They just didn't have a reason to write it down and publish it because it didn't need to be sold. You didn't need a patent to crush a seed. You didn't need a distributor. You didn't need a middleman. And that, right there, is exactly the problem. From a commercial standpoint, something this accessible, this renewable, this free, it's a disaster. You can't build a billion-dollar industry around a tree that grows in a ditch on the side of the highway. So it got overlooked. Deliberately, as it turns out. But we'll get to that. For now, understand what we're talking about. The Osage orange seed. Small, oil-rich, packed with a specific class of chemical compounds that affect snake behavior at a neurological level. Compounds that researchers were actively studying in the mid-20th century, producing results that were, by all accounts, extraordinary. Results that were never published, research that was quietly closed down, and a remedy that millions of people have been paying to replace with inferior chemical alternatives ever since. And here's what makes this story so much bigger than one seed from one tree in one country. Because the Osage orange isn't alone in this tradition. It's just the American chapter of a much older book. Go back far enough, and you find that virtually every agricultural civilization on Earth developed some version of this practice. Some natural plant-based boundary between their living spaces and the reptiles they feared. The specific plant changed depending on where you were standing. The principle never did. In parts of West Africa, certain communities have used the crushed seeds and dried bark of plants in the Strophanthus family for generations, spreading them along the perimeters of village gardens, tucking them beneath the thresholds of doorways. The elders in these communities didn't explain it in terms of chemistry. They didn't need to. They explained it in terms of results. The snakes stayed out. That was enough. Move to India, and you find similar traditions built around plants, like the Indian snakeroot, Rauvolfia serpentina, whose very name tells you something about the relationship people had with it. Ayurvedic practitioners referenced it for centuries, not just as a medicinal herb, but as a ward. Something you kept near, something that changed the energy of a space, as they described it. Today we'd describe that differently. We'd talk about volatile organic compounds and olfactory disruption. But the observation underneath both descriptions is identical. In rural China, certain provinces have long-standing traditions of planting specific aromatic herbs along field borders during planting season, not randomly, specifically during the months when snakes are most active. The timing isn't superstition, it's ecology. Those same communities noticed, over hundreds of years of observation, that the snakes moved differently around those borders, that the incidence dropped, that the pattern held. Come back to the Americas, and it goes deeper than Appalachia. Indigenous communities across the Southeast had been using Osage orange and related plants long before European settlers arrived and figured out what they were looking at. The Comanche, the Osage themselves, the tree is named after them. They used the wood, the fruit, the seeds. Not always for the same purposes, not always with the same understanding, but the knowledge was there, woven into practice. What's remarkable when you look at all of this together isn't the variety, it's the consistency. People on opposite sides of the planet, with no contact with each other, working with completely different plants, arrived at the same conclusion: that certain seeds, certain crushed plant materials, kept snakes away. That knowledge didn't come from laboratories, it came from thousands of years of watching carefully and remembering what worked. And it survived. Through colonization, through industrialization, through the wholesale replacement of traditional knowledge with commercial products, it survived. In the memories of grandmothers, in the practices of small farms, in the corners of the world where no one tried to sell you a better solution, because there wasn't one. So what's actually happening when you crush one of these seeds? What is it chemically that makes a snake turn around and go the other way? Because for a long time, the answer to that question was either ignored or buried, but the chemistry itself never changed. It was always there, waiting for someone to look closely enough. The seeds most consistently associated with snake repellency, and the one that kept appearing in the research before that research got quietly shelved, contain a group of compounds called phenolic acids, specifically compounds like caffeic acid and ferulic acid. These aren't exotic, hard-to-pronounce laboratory creations. They occur naturally across dozens of plant species. Your body processes them when you eat certain vegetables. But in concentrated form, released when a seed is crushed, they behave very differently. Here's what matters about snakes specifically. A snake doesn't experience the world the way you do. It doesn't rely primarily on eyesight. It relies on chemoreception, the ability to detect chemical signals in the environment through its Jacobson's organ, a specialized sensory structure in the roof of its mouth. Every time a snake flicks its tongue, it's collecting chemical information and delivering it directly to that organ. It's essentially tasting the air, reading the landscape chemically, constantly, with extraordinary sensitivity. That sensitivity is exactly what these compounds exploit. The phenolic acids released from crushed seeds don't harm the snake. They don't poison it. What they do is overwhelm that chemosensory system with a signal the snake reads as danger, as wrong, as a place it does not want to be. The biological response is avoidance, simple, immediate, and consistent. There's another layer to this. Some of these seeds also contain sulfur-bearing compounds, the same basic chemical family responsible for the smell of garlic, of onions, of certain other plants that animals across multiple species have learned to avoid. Sulfur compounds are volatile. They disperse into the surrounding air and soil. They linger, and they register to a chemosensory system like a snake's as something deeply, instinctively unpleasant, not a learned aversion, a hardwired one. What's interesting is that researchers who looked at this in the mid-20th century weren't surprised by the findings. The chemistry made sense. The mechanism was logical. The concentration levels needed to produce a repellent effect were achievable through something as simple as crushing seeds and distributing them around a perimeter. No synthetic production required, no patents necessary, no supply chain, no markup, no recurring purchase. And that last part, that's where the story gets uncomfortable. Because by 1961, a small number of agricultural and chemical researchers had documented enough to suggest that this natural approach was not only viable, it was effective in controlled conditions. They had the data, they had the mechanism, they had a repeatable result. What happened next had nothing to do with the science. What happened next requires understanding the world those researchers were operating in. By 1961, the American chemical industry wasn't just profitable, it was powerful in a way that's difficult to fully appreciate from this distance. The post-war economic boom had transformed synthetic chemistry into something close to a national religion. DDT had been celebrated as a miracle. Organochlorines were being sprayed on everything. The message being delivered to American consumers, to farmers, to homeowners, was consistent and relentless. Nature had a problem, and industry had the solution. That framing wasn't accidental. It was a business model. Into that environment walked a handful of researchers with data suggesting that something you could grow in a garden, or buy for almost nothing at a market, could solve a problem that chemical companies were actively developing patented products to address. Snake repellent was a growing commercial category. Pest control broadly was becoming a multi-million-dollar industry with significant lobbying influence and deep relationships inside agricultural research institutions. The timing could not have been worse for an inconvenient natural alternative to surface publicly. What the historical record shows, and the record here is fragmented deliberately, which is itself a kind of evidence, is that the research didn't fail peer review. It didn't collapse under scrutiny. It simply stopped moving forward. Funding dried up. Publications were delayed, then quietly shelved. Researchers who had been working on natural volatile compound repellency found their grant applications returned, their institutional support withdrawn. One researcher, whose name appears in correspondence recovered decades later, reportedly described the situation to a colleague as being told, without ever quite being told, that this particular line of inquiry was not going to be a priority. That's how suppression often works. It doesn't announce itself. There's no memo that says bury this. There's just suddenly no money, no platform, no pathway to publication. The research exists in the form of internal notes and preliminary reports that never became papers, papers that never became citations, citations that never became a body of established knowledge. The chain was broken at multiple points, quietly, effectively. Meanwhile, the chemical solutions moved forward. Naphthalene-based repellents, many of them genuinely toxic, not just to snakes but to children, to pets, to soil ecosystems, were developed, patented, manufactured, and marketed. They were sold in hardware stores for decades. Some still are. The patents generated revenue. The revenue funded lobbying. The lobbying shaped agricultural policy and research funding priorities. The cycle reinforced itself. And somewhere underneath all of it, the data about crushed seeds and sulfur compounds and hardwired chemosensory aversion sat in boxes that nobody with institutional authority had any financial incentive to reopen. This is not a conspiracy theory in the dramatic sense. It doesn't require a shadowy room full of executives deciding to suppress truth. It only requires something much more ordinary and much more durable. An economic incentive structure that made certain knowledge inconvenient, combined with the institutional power to make inconvenient knowledge invisible. That combination doesn't need to be coordinated to be effective. It just needs to persist long enough that the people who knew are gone, and the people who remain never think to ask why the research stopped. 60 years is more than long enough. And once that cycle locked into place, it became nearly self-sustaining. Think about what those 60 years actually looked like on the ground. Families moving into new homes near wooded areas, near fields, near water. Worried about copperheads in the garden, rattlesnakes near the fence line, water moccasins along the creek. What did they do? They went to the hardware store. They bought what was on the shelf. They trusted the packaging because the packaging had a brand name and a warning label and an EPA registration number, and that combination reads like legitimacy. It reads like science. It reads like someone somewhere did the work and confirmed this was the best solution available. But the best solution available and the best solution that exists are not always the same thing. Sometimes they're not even close. The chemical repellents people used, and continue to use, carried real costs that were rarely discussed on those packaging labels. Naphthalene, the active ingredient in mothball-style snake repellents, is classified as a possible human carcinogen. Children who play in treated areas can absorb it through their skin. Pets, with their lower body weight and constant contact with the ground, are particularly vulnerable. And soil ecosystems, the complex microbial and invertebrate communities that make healthy gardens possible in the first place, can be disrupted by repeated chemical applications in ways that compound over years and decades. None of this was unknown. Studies documenting naphthalene toxicity in mammals were available. Concerns about soil contamination were raised in environmental literature, but the product stayed on shelves. The marketing budgets stayed large, and the alternative, The seed-based, naturally derived approach, with its documented historical use across multiple continents and its compelling early biochemical data, remained invisible. Not because it had been tested and failed, because it had been tested and then quietly set aside before anyone powerful enough to amplify the results decided it was worth their time. What that cost ordinary people is genuinely difficult to quantify. Decades of unnecessary chemical exposure. Decades of spending money on products that, in controlled comparisons, perform no better, and in some studies perform worse, than natural alternatives. Decades of trusting an industry that had structured its entire economic model around making sure you kept coming back to the store. And perhaps most frustratingly, decades in which the knowledge that could have changed things was not lost. It was just buried. Sitting in archived journals, in old agricultural extension reports, in the collective memory of communities that never stopped using what had worked for generations, waiting for someone to finally look. So here you are, 60+ years later, and the question that actually matters is a practical one. What do you do with this information right now, today, in your own yard? The seed in question is the Osage orange, sometimes called a hedge apple, a horse apple, or a mock orange, depending on where in the country you grew up. The fruit itself is that strange, wrinkled, bright green sphere you may have seen piled in baskets at farmers markets in the fall, often with a handwritten sign nearby that says simply, "Keep snakes away." Those signs were not superstition, they were institutional memory in cardboard form. The method is almost insultingly simple. You take the fruit, or the seeds extracted from it, and you crush them. The crushing matters. An intact fruit sitting on your porch does relatively little. But when the internal tissue is broken open, the compounds responsible for the repellent effect, primarily the isoflavones and specific oleic acid derivatives identified in the early biochemical work, are released and become volatile. They spread. They linger in the air close to the ground, which is exactly where a snake lives and moves and breathes. You place the crushed material around the perimeter of the area you want to protect, along fence lines, near foundation gaps, around woodpiles, which are exactly the kind of habitat a snake finds attractive, around garden beds, near any entry point where the ground meets a structure. In dry conditions, you will need to reapply roughly every 2 to 3 weeks, because the volatile compounds do dissipate over time, especially in heat. After rain, reapplication is worthwhile because moisture accelerates breakdown and dispersal into the soil rather than into the air. Some people supplement with the whole fruit placed at intervals and then periodically replaced when it begins to decay past usefulness. Others extract the seeds, dry them partially, and crush them as needed through the season. Both approaches appear to work. The results that people report are consistent enough to be meaningful. Yards where snakes had been a recurring seasonal presence, sometimes multiple sightings per week in warmer months, go quiet. Gardens that had seemed to be permanent habitat become inhospitable. The anecdotal record on this spans generations and crosses continents, and as we've now established, it has biochemical backing that was documented in peer-reviewed work before being systematically deprioritized. This is not a magic solution. It is not a guarantee. No repellent of any kind is. But what it is a documented, historically validated, chemically coherent approach that costs you almost nothing, introduces no toxins into your soil, poses no risk to your children or your pets, and in head-to-head comparisons with commercial naphthalene-based products, performs as well or better. The knowledge was never gone. It was just waiting for someone to use it again. You now have everything you need. The seed, the method, the history, the science, none of it is complicated, and none of it requires you to spend money on products that were designed to replace something that was already working. Start simple. Find the fruit, crush the seeds, place them where the activity has been, see what happens over the next few weeks, keep notes if you're inclined, because your observations matter. The peer-reviewed record on this was thin not because the evidence was weak, but because the funding dried up. Every person who documents their own results is adding something back to what was taken away. And then tell someone. Tell your neighbor who mentioned a copperhead near the garden. Tell the person in the community group asking what to do about a snake problem under the porch. Share this, not because it's a secret that needs protecting, but because it's practical knowledge that deserves to circulate freely. The chemical industry spent decades making you dependent on products you never needed. The answer was in the yard the whole time, or close enough to one that it cost almost nothing to find it. That's the part worth remembering. And more importantly, that's the part worth passing on.